So this talk or this showcase is about to show some, some extra uses you can use or alternative uses of Dagger, because we all know we can use Dagger for CI, but there's actually also a great possibility of using it for something else, and I'm going to show a few of those use cases here in this talk. So a Dagger can be, of course, be used as a CI system, but it can also be used as programmable orchestration. A little bit of a mouthful. A deployment tool or a distribution mechanism. And what I mean by that is programmable orchestration. Is that you can use a normal programming language, and orchestrate between different tasks in Dagger. So you can get it to build stuff, you can get it to run stuff, and you don't have to depend on the host's tools at all, which is super cool. You can also use it as a deployment tool, which basically means that you can use it as a small tool that does a very specific thing, and just take it in, use it. You don't have to install anything. You just pull it in and use it. And this is especially interesting in the last paradigm here, distributed distribution mechanism. This means, and I'm specifically interested in from a developer's point of view, that I can actually ship software to my developers without having them install tools. The only thing they need is a Docker runtime, Golang, or in this case, Rust. And that's everything they need. They don't need some sort of esoteric tool installed to be able to do a certain thing. It's also a way of getting compatibility between all the platforms. I can expect that my result will be sort of the same between Linux, Mac, and Windows. So yeah, that's pretty cool. I'm going to focus mostly on these middle parts here. So programmable orchestration and the deployment tool. Yeah. So we are going to jump straight over CI because you already know that thing. So, orchestration. You can of course use it for tests, spin up service containers, do that sort of stuff. But I'm mostly interested in specifically in tooling. How can you actually use it, or how can I use it to ship software to my developers, and they can just use it and do all sort of cool stuff in their workstations. So, first of all, we need to talk about how do you actually ship software to developers, because when you run this in CI, you don't have exactly the same concerns as you do when you ship to a client. This means that you also have to think about speed. When you run a tool on a command line, speed really matters. If something takes 2 minutes, a developer is not going to sit and wait for a thing to, run for 2 minutes before, running a CI job or something else. You need the speed. So in this case here, I have, given a little bit of a sneak peek on a benchmark as well on how to actually achieve speed with certain pros and certain cons. So the first thing is, you take in, your source code, Dagger, you build it and you run it. That's by far the slowest. The next one is pulling in an application image. So that is basically an image or a container that has been built, or an image that's been built, put in GitHub container registry, and whenever you need it, you pull it and run it. The next one is a little bit esoteric, but that is, you have a runtime of some sort. In this case, a wasm runtime. So that's a Dagger image that has a WebAssembly runtime. You pull in a wasm binary, for example, from GitHub releases, and you run that. That's quite fast, and also super great compatibility between architectures and whatnot. And then the last one is also familiar to some. You have a Scratch image, or just a simple Debian image or Alpine image, and you just pull a binary and run it as well. And there's some pros and cons between all of them. Building an image is extremely slow initially. It will of course be cached, but first time you run it, it will take a few minutes, probably. The next one, building an application image, is also quite fast, but not really shareable. So, you'll have a lot of images on your machine. The next one wasn't binary, and the fourth one are sort of similar in the sense that you share an image, and you just have the extra layer on top. And I'm going to show a few of them. So the first one here is this benchmark I've done. So I've done a benchmark thing where it's not super scientific. It's just to give an idea on the difference in speed. But what we do here is you can basically run the benchmark, and it's going to actually do the 4 steps you saw here before. So, it's actually going to do all these things. I'm not going to do it now, but if you go in here, and this is in seconds, this is the first run. So, you can see that building an image It takes 55 seconds for a fairly basic app. It's also a Rust app, so it's a little bit slower than you would in Golang, but you can see it's super slow. Pulling an image by itself, incredibly fast. And then somehow the Russian binary and run binary is a little bit slower. But you also have to think about this is the same as a web world. You might have Bootstrap that is shared between a lot of web pages that you have cached once, and then they're available for all the other websites that also use Bootstrap. This is kind of the same thing. This wasn't runtime would just be available the next time somebody needed a tool. So this, you can kind of think of this the same way as you would fetch the Dagger engine. You also do that once, and that's reused between all the Dagger tasks. So there's great boon in second and third runs of these last ones, but by far the fastest is just pulling an image, and also the most straightforward. And feel free to go and look at the code if you want. Yeah. All right. I'm going to jump ahead. And next one, I'm going to take a more specific use case. So this is a tool I built. You might know Renovate, but Renovate is a tool that allows you to update your dependencies in your repository or set of repositories. And you can do this in various ways. But one thing you can do is you can get a Docker image, run it, point it towards your GitHub repositories or Git in this instance, and just let it go ham on it. But the problem with Renovate is going to take the repositories one at a time. So like me, if you have 300 repositories, it's going to take a few hours before it runs through the list. And that might not be desirable for your use case if you have so many. So what I've built here is a simple thing on top of Dagger. And now we get into really the orchestration part. So in this tool, we can actually use Dagger to run the Renovate part, but use the logic of a normal program to actually schedule, hey, I would only like to run 4 at a time, because Renovate in this case is super expensive to run. So in this case, I'm only running 4 at a time, I think. Right? Oh, 3 at a time. So it runs 3 at a time, and it uses some various Rust logic that is a little bit more complicated than it probably should. But the idea is, I can run 3 at a time, and it just continuously run through. And I can also show that if I go to this one here. So I'm in the same repository, as you can see, and I can do, what was the command? I think it was cargo run. So if I do this, it's going to load in all of my repositories first, and it's going to pick one at a time. And you can see it fetches some image. I probably wiped the Dagger engine just before this demo, so it's going to fetch the image first. And the good thing about Dagger is also that there's deduplication and all that fun stuff. But once it's done, it's also a super large image. The image is 1 gigabyte, so it's going to take a while because it includes all the dependencies to update dependencies in various languages. But it's actually going to do, 3 at a time. So when one is done, it's going to put it back on the stack, and it's going to wait. And, I get all these task scheduling things that would normally be quite tricky to do in, Bash and whatnot. Of course, possible, but, this is a nice use case, and I'm just going to let it run here so we can actually see that it does have. Yeah, we can see multiple of them running. One. Yeah, it's a quite large image. I think it has like 16 layers or something. It's really extremely large. Anyways. And, that's also why I want to limit it to 3, because, now you can see it begins to run, and it runs, and you can see a new one was scheduled running in queue. It's going to run the next ones, and so on and so on and so forth. So this allows us basically to choose and say, hey, if we have enough compute, we can basically scale this up so we have 1 per repository that just runs whenever needed. We can also, I have another tool called Git Events. So every time something is updated, we just fire off this tool again. So anyways, it was just a quick thing, some things you can do on Dagger that would normally be a little bit tricky to do. You can, of course, just call out to a Dagger run with the same environment variables, but here you actually keep and be in the language that you prefer to use. So yeah. All right. And all of it is open source as well, so you can just go ahead and take a look at it if you want. Yeah. So the next one is what I alluded to before. So this is actually the Dagger wasm runtime. And again, this allows us basically to run custom WASM assemblies on top of Dagger or inside of Dagger. And the thing is, normally to execute this WebAssembly, you would need to ship a runtime, kind of like you do with Docker. So you would have to ship WASM or WASM time or something. I don't want to do that. That's just an extra tool. So why not just wrap that in Dagger and just have that available? And now you actually have the ability to run WebAssembly code whenever you want. So that's what I've done here. And also using Dagger to build it. And it's just a simple tool. Oh, it's just a test binary. Yeah, so in CI here. CI, finally, CI. So here we go. And here I actually built both WASM time and WASMA, if you want. I only publish WASMA, I think. Oh, I only have it locally. Doesn't matter that much. Yeah, you still have the architectures you have to deal with, but now you actually only have to do cross-platform images one time because WebAssembly is cross-platform. So, you don't have to, you can share architectures. So it's actually super cool because now you don't need a lot of different versions of your image, even though Dagger actually makes that super fast as well. Anyways, yeah. And this one was actually also used in the previous benchmark. I didn't want to run that right now, but it's actually also used there to do the WASM demo. All right. Next up is Dagger as a deployment tool. So in this case, the preferable approach would be to package up a CLI or something, put it in a Dagger image or Docker image, and just run it. And that's what I've done for my personal blog. So it's a little bit over-engineered maybe, but we like to do that. So in here, what I do is I like to write my articles in Obsidian. You could also do it in Notion and whatnot. But I would like not to have my source code in that same vault as well. So what I do here is I basically sync my entire vault to my Git instance, and using a simple tool. Let's go find it here. I basically pull the required things, pull the articles, format them as I want, and then re-upload them again. So now I've actually achieved compatibility between two tools using this simple thing. And I can just execute this whenever I want using my normal blog CI system. So I can just trigger rebuild and it will fetch all the new articles and whatnot and upload it. And that's actually also the last tool on the list, update deployment. It's also a little bit of a simple tool that basically goes and updates a image tag inside of a Docker Compose thing. Let me just see if I can find it. Deployments. I think it's this one. Not really. That's not that one. I'm not that great at naming. Take this one. So in here, it would actually just update the image tag. Yeah, I don't know if I can see. You can probably see blame here. You can see it does update Docker Compose and whatnot. So it's a machine user that has done this. So it's pretty nice, just a simple tool. It's pretty quick to build. And the only thing, this repository, or the blog actually knows about, it just needs to know about that it needs to pull a Docker image. It doesn't have any source code at all. It just says, hey, I would like, for example, the update deployment thing, and done. And then if I wanted to, I could get Renovate to actually update this tag here for me. So it always fetches the newest one. Yeah, so this is just a simple, small sharp tools. Then the distribution mechanism, I won't go too deep into this. But for all these things I've built, we use a project called Shuttle that's built by my current company. And what it allows us to do is it's kind of like Mage, if you know the Golang Mage tool. But this actually allows you to share parts of this plan between different repositories. So for example, you can have a master repository plan that has a recipe for how to build and maintain a Golang application, for example, for Kubernetes manifests, tests, CI, and whatnot. And just recently I added Golang support for it. So you can do the same thing as you can in Mage. You can just execute a Golang function. And this integrates very nicely with Dagger as well, because Dagger is just Golang. We can share plans, we can reuse code and so on. So it's super nice for a mage-like use case as well. And allows us to share packages. We can have a team that can actually maintain, the security team can just maintain a library that contains how they would like to scan Docker images. They don't have to sit in this soup that is these large repositories that contain, an entire company's CI structure. They can just have their own little library, and we can pull them in the places we need it. So it's super convenient. Yeah, and that was basically it.